In today's video, I'm going to show you how to optimize your Docker images to get them ready for production. I'm going to use the Docker setup for our MERN application from last video as my base setup, and then I'll just make some minor tweaks to it. First, let's understand why we need to optimize the current setup. So here's a diagram of our Docker setup, and first let's start with our API. So it's currently running a TypeScript dev server on the container, and it has all of the dev dependencies. The size of our image is about 293 megabytes. And this is great when we're developing locally because we need TypeScript and all of the development dependencies to enforce the type checking. However, in production here, our container should just be our compiled JavaScript with no TypeScript and no dev dependencies. We're also just going to be running a normal node server instead of the TypeScript dev server. And since we don't have the extra dependencies or the extra TypeScript code, the size of our image actually goes down to only 225 megabytes. When we're running in production, we want to decrease the size of our containers and images as much as possible and get rid of a bunch of code that we don't need. For our front end, in the development environment, we also have all of our dev dependencies and we're running the Vite dev server with hot module reload. The size of this image is 332 megabytes. However, in production, here's where we get a pretty big change. Instead of running a Vite dev server, we're actually going to run a Caddy file server. Because all this container really needs to do is serve the static files that were built into the dist folder. So when we go to production, we're going to run the build command, and it's going to take all of our code and compile it down to just static HTML and JS files. And then this container is just going to serve those files back to the client. With this setup, our size goes down to 49 megabytes, which is a huge difference from 332. Lastly, for our Caddy container, when we're running it locally, we are generating self-signed certificates and we're using a local domain name. However, in production, we want to generate valid certificates with Let's Encrypt and also handle real domain names and then add any extra Caddy modules that we may need. For example, I added the rate limit module because in production you want to have some sort of rate limiter. That's not built into Caddy itself, so I actually had to install that as a separate package, and that's why you see the size of the container in production go up from development. It's because of that extra added package for the rate limiter. With all that out of the way, let's jump into the code. So I have the starting files open here, and if you want to reference any of the code that I'll write in this video, make sure to check out the GitHub repo in the description and go to the YT Docker prod branch. So again, I'll leave this in the description below, and make sure you're using this branch to reference the code I write in this video. I'm going to give a brief rundown of where we're starting from. So we built this docker-compose file, and we have a Mongo service which just runs the base Mongo image, and we set up some ports and volumes. For our API, we have a separate Docker file, and if we just look at that briefly, all we're doing is copying the dependencies, installing them, and then running the dev command, which starts up our TypeScript dev server. Then we have a front-end service, which is very similar and has its own Docker file. In there, we just copy the dependencies and copy all the source code. Then eventually we run the npm run dev command, and that's going to spin up the Vite dev server. Lastly, we have our Caddy container, which just runs the base Caddy image, and we set up some volumes for the Caddy data and Caddy config. So there's not really much going on here. Let's start by creating a separate docker-compose file for our production environment. We'll rename the current one to docker-compose.dev.yml, and then I'll just copy it and rename this one to just docker-compose. So this will be the production one, and the dev-compose file will be the one with .dev in it. Now let's go and update some of the configuration. First, we'll start with our Mongo service. So we don't want to expose any of these ports anymore, because when we're running this in production, we don't want to expose the host port, because the host port will be the port on our VPS or our web server out there on the internet. And if you expose this port and don't have any firewall rules set up, then anyone can hit your server on that port and get access to your database. So in production, you don't want to expose that host port on your VPS. The only reason we had it in the development environment was so I can connect to the database locally through an app like Compass. Our API, however, was connecting through the Docker network, so it didn't even need that port. We can keep this volume and also the network, and that's about it for the Mongo service. Now, our API is going to require a bit more changes. So first, I want to get rid of the volumes here. And we don't need these anymore because when we're on our production server, we're not going to be trying to map the container source code to our host source code, because on the VPS, we're not going to be updating our backend code. So we don't need to map any local directory on the host machine to the container, because by the time it's on the VPS, all we're going to do is git pull to get the latest source code and then build our image. Once the image is built, it's going to be finalized and no longer update. So we don't need those volumes anymore. The last thing we need to do is update our build property. So right now we're giving it a context of backend because that's where our Docker file is. And we're telling Docker Compose to just use the Docker file. And if I open this up right here, all we're doing is installing the dependencies and our source code and then running the dev server. For our production build, we don't want to run the dev server. We want to just run the compiled JavaScript code with no dev dependencies and only the compiled source code that we need. To do that, we need to use multi-stage builds in Docker. Multi-stage builds are basically used to slim down your final resulting image. So I can go up to the top, and right after I define this image, I can give it a stage name. So I'll say as development, then I'll add a comment above, and I'll just say development stage. And then I can go to the bottom and add another stage. So I'll call this one production stage. And we're going to use the same Node 18 base image for our runtime. And then we'll rename this stage to production. Now we need to basically define the set of instructions as if we were starting over. So I'm going to copy these commands here and just paste them below. So we'll set our working directory to /app. We'll copy our package.json files. And then when we install the dependencies, we don't want to install all of the dependencies. We only want the production dependencies. To do that, we can specify an only flag and set that to production. And what that's going to do is only install the dependencies in this object here. It will not install the dev dependencies. So that's going to slim down our image a little bit because we won't have all of the code for these libraries. After installing the dependencies, we want to copy the source code, but we don't want to copy everything in this backend directory because these are all the TypeScript files. We only want to copy the compiled output. So after we have built our app, we want to copy that compiled JavaScript code. To do that, we need to first build our app. So let's go to our development stage, and after copying all of the source code and dependencies, I'm going to run npm run build. And this is going to run the build script in our package.json, which is this up here. And it's going to compile all of our TypeScript code to JavaScript. And in our tsconfig, we specified the outdir to be dist. And so all that code gets compiled to this dist folder. So after we run this build command, we should have all of the necessary code to run our app in that folder. So let's come down to the bottom and we'll copy from the development stage. Then we need to give it the path of that container or this stage, and that's going to be /app/dist, because when we run the build command, we're in the app directory and it's going to build it to the dist folder. And so that's where all the code is going to live. And then we want to copy it to our current container on the dist folder. After we've copied all of our compiled code, we just need to run the server. So we'll say command, and then we'll run node dist/index.js. And we need this dist folder because we're copying it to that folder here. So now we have two different stages. We have the development and production. Because of that, I need to update my Docker Compose file to point to this production stage so that it only contains this configuration in the final container. So let's go back to our Compose file, and instead of specifying the Docker file, we're going to specify a target. And then that target, the value will be the stage name. So in our case, we want production. So when we run Docker Compose up and it looks at our API service, it'll see to go to the backend directory and use the production stage. So it'll look at our Docker file, go to this production stage, install our production dependencies, and then it'll see copy from the development stage the app/dist directory. So then it's going to run our development stage, install all of our dependencies, including development ones. Then it'll build our app and then copy all of that code into this production container. After this command runs, it's just going to discard the development container that it built on the fly because we're not using it anymore. Then finally, it's just going to start up our server here and spin up. Before we move on to the front-end container, I want to update our build step. So when we run the build command here, again, it's going to run this build script in our package.json. And in here, I just want to update this to run rimraf dist and the TypeScript compiler. So this is basically just going to remove the dist folder, which was the previous build, so that we have a clean directory to compile our code into. And then we're just going to run the TypeScript compiler, which will do all the work we need. In order to use this library, we have to install it as a dev dependency. So we could do npm install -d and then rimraf. So with all that installed, this should work as expected now. Let's also update our Docker Compose dev file to use the development stage. In our API here, instead of Docker file, we'll set this to target, and the value will be development. So with that, we should be good for our API. And let's go down to our next service, which is the front end. First, let's get rid of our volumes because, again, we don't need to map anything from the host machine in production. And we also can get rid of this command because we're no longer running a Vite dev server. We're going to be running a static file server with Caddy. Now let's go and update our Docker file. Again, I'll add a comment here. So development stage, and then we'll add as development. After we've copied all of our source code and dependencies, we want to run the build command. So I'll say run npm run build. But here's where it gets a little tricky. So when we run the build command, it's going to run the build script in our package.json, which just runs vite build. In our environment variables, we specified a public environment variable. So every variable that's prefixed with vite _, that will get injected in at build time into the final source code. So if you look at this dist directory and you go to the compiled JavaScript, in here you can find that variable. So api.auth, you'll see here is our base URL. So when we ran the build command, it basically looked at our code, and anywhere that we were using this Vite API URL, it just injected this value in. Now the problem comes when in our Docker file, when we run this build command, it doesn't know about our env file. Even though we specified it in our Docker Compose right here, this only gets used when the container's running. But when we're running the Docker file, this is building the image, which will then run on the container. So at this point in time, we can't just access this env file. The way I was able to get around this is to just inject the environment variable in right before the build command. So we can just do something like vite API URL equals, and then I'm just going to copy this value and paste it in here. So now right before it runs the build command, we're going to set this variable in the environment, and it should get injected in properly in the final build output. Now let's add our production stage. If you remember from the diagram, this is going to be a static file server. So it's no longer going to use the node image. Instead, we're going to use the Caddy Alpine image. So we'll say Caddy, and then we'll use the tag to-Alpine. Then the stage name will be production. And in here, we want to copy the Caddy file because anytime we use Caddy, we need a Caddy file. So we'll say copy Caddy file, and then we're going to copy it into this path on the container. So this is just as we did before, and we're going to create the Caddy file in a second. The last thing we need to do is copy all of our compiled code onto this container so that it can serve it statically. So I'll say copy from the development stage, and after we ran this build command, it's going to put that output into a dist folder. You see that here. So we're going to copy from there /app/dist, and we want to copy it to the /srv directory on the Caddy container. So we're going to reference this in our Caddy file. Now let's create our Caddy file for this static file server. Under Frontend, I'll create a new file. We'll call it Caddy file, and then I'm just going to paste this in. I have some global options here, and this code is just needed to trust the proxy from our other Caddy container that handles HTTP traffic from the internet. And since this is only running internally on the Docker network, we can just expose port 80, and we don't need to worry about encrypting the traffic because it's all going to be running on the local network. So the only thing ever accessing this is our other Caddy container. And this is just some extra configuration that's going to say all of our root files will be at this directory. And when a request is made to this server, we're going to try that path. And if it doesn't return any path, we'll return the index file. Since a React app just has one index file, it's always going to return this, and then React will handle the client-side routing from there. And lastly, we just need this file server directive to tell Caddy that this is a static file server. So we can give this a save, and now it should be copied over properly in this line here. And now we need to update our compose file to point to the production stage. Let's go back to the compose file, and in here we'll add the target, and that's going to be production. Then let's not forget to go to our dev Docker file, or docker-compose, and we'll set our front end to development. Let's close out of this. And I'm realizing we also don't need the env file in the production compose file because this is just a static file server. So it's not going to be using any environment variables there. Now let's move on to our Caddy service. First, let's get rid of this image here. So we won't be able to just get away with the Caddy image. We're going to have to create a separate Docker file because we need to install an extra dependency that's not available in the base Caddy image. That's the rate limiter. So in our Docker file, we'll use a Caddy base image, but then also install the rate limiter. Let's update this to use a build context. And the context will be the Caddy directory here. And the Docker file will just be called Dockerfile. Now let's create that Docker file in the Caddy directory. And in here, I'm just going to add a comment saying only used in production, because in development, we're just using the base image for Caddy here, and we don't need to add the rate limiter in development unless you really want to, but I'm going to leave it as just the base image. Now we need to pull the base Caddy image. So we'll say from Caddy, I'm going to specify to-builder. And I'm using the builder tag instead of the Alpine because we're going to need to install a dependency using xcaddy. So this stage will be called builder. And now we need to install the rate limiter package. We could do that by running the xcaddy build command, and then this is the source of the package. After that, we could specify our final stage. So we'll just say from caddy to-alpine, and then we just want to copy this dependency that we installed in the builder stage. So we'll say copy from the builder stage, And the path on the builder stage is this user/bin/caddy, and we're just going to copy it to the same path on the container. We also need to copy the Caddy file for this production container. So I'll add that right above. We'll say copy Caddy file into this same directory. Now we need to create this Caddy file. So I'm going to do the same thing as before, where I'll rename the development Caddy file to caddyfile.dev, and then I'll create a new Caddy file for our production one. I'm going to copy the contents of our dev Caddy file and just tweak them a little bit. We're not going to be using local certificates, so I don't need that line, but I will grab the other two. And instead of going to the front-end container on port 5173, which was the dev server, I'm going to forward it to port 80. That's because in our front end, this Caddy server, which is our static file server, it's going to listen on port 80 here and serve files from there. So make sure that you add port 80 here. For our API, this reverse proxy will stay the same because our compiled code still runs on port 4004. However, I'm going to add a few things for our production proxy. First, I want to add some security headers. So I want to get rid of this X powered by and the server header because we don't want to leak that information to the client. And these are just some other options that will improve the security of our server. And I'm not going to go in depth onto each one of these, but you can feel free to look them up. The last thing I need to add is our rate limiter. So right below these headers, I'm going to paste in the rate limit configuration. So we have this rate limit block, and we define a zone and then a name for the zone. So I'm calling this one API limit, and the important keys are the events and the window. So I'm basically saying I only want to allow a maximum of 100 requests in a 1-minute window. So if someone tries to send 101 requests, they're going to get rate limited within that minute. Now I have a comment here for using the Cloudflare proxy because this rate limiter is using the IP address. And if you're not using a Cloudflare proxy, then you want to use this key. However, if you are using Cloudflare and you're using their proxy service, the client IP is actually found on this header, which is different than the default header sent without a proxy. So if you're not using Cloudflare, just use this key. Since I'm using Cloudflare, then I'm just going to comment that back out, but just keep that in mind. I also have a second rate limiter, and this is for bursts. So this rate limit would account for a longer window, like 1 minute, whereas the burst limit would only account for very short bursts of time. So in 1 second, I want to limit it to 20 requests. So if someone sends more than 20 requests in 1 second, then they'll get rate limited. And it's usually a good idea to have 2 rate limits, one for just burst requests and one for a longer period of time. Just make sure your app or your front end doesn't make this many API calls in the source code so that the user will be rate limited unintentionally. I think 20 requests in 1 second is a good number, but you can tweak this as you like. So that's it for our API server block. And I actually want to add one more block up here, and that's adding a www redirect. So I'll add another block here saying www.auth.localhost. And then we just want to redirect to our auth.localhost domain without the www. Then we'll also add the permanent option after that. So this will probably be handled by your DNS configuration through either an A record or CNAME, but it's good to have this line here in case you're not handling it there. So that's it for our production Caddy file. Now let's go back to the Docker Compose, and it should be using that Docker file, which then uses that new Caddy file. And so we don't actually need this volume mount anymore because we're copying it in the Docker file right here. So let's get rid of this volume. Let's also not forget to update our Docker Compose dev file to now use the caddyfile.dev because we renamed it to that. So make sure you don't forget to update that here. The last thing we need to do is make the domain name dynamic in production. If you look at our production Caddy file, you'll see that this domain is hard-coded, and this won't be the actual domain we use in prod. So we need to make this value dynamic, and we can do that through environment variables in Caddy. To use an environment variable, you can just open up curly braces and then do a $sign and the name of the variable. So I'll call it domain name. And we can give it a default by adding a colon, and I'll just put invalid because in production, this variable should always exist. Then let's just replace these other values with that environment variable. So that looks good. Now we just need to pass this environment variable into the Caddy container. And we can do that by going back to the compose file. And right below our ports here, let's pass an environment property. And we'll call the variable domain name. And instead of hard coding it to be your production domain like this, I also want to use a variable for this. For this variable, I'll use a Docker environment variable. And to reference that, you need to do a $sign and then curly braces, and it'll just be the same name. And this should actually be a colon, not an equal sign. Now we need to set this environment variable in a .env file at the same level of this Docker compose file, and it'll automatically load it in while it's running the Docker compose file. So at the root of our project, let's add a .env file. And we want the variable to be domain name, and then you can put your production domain. For now, I'll just set this to auth.localhost so we can test the production build locally. And then I'm also just going to make this a sample env. So now people will know that this should be filled out. So that handles the Caddy file here, and we can close out of this. And for now, we can keep our dev Caddy file as just using hard-coded local domain names because we don't really need an environment variable for that. The next place we need to update is our front end. So if you look at the Docker file in our front end, we have this build command, and right before we build, we're setting the Vite API URL. And right now it's hard-coded to our auth.localhost domain. And that's because we needed this variable to be injected in at build time, and I couldn't find a way to pass it in without doing something like this. However, we could make this value dynamic by just specifying an argument. So right above this line, let's define an argument. We'll call it Vite API URL. And then we can reference it instead of just using this hard-coded string. I'll do $, open braces, and then the argument. Now we need to pass in this argument in our Docker compose file. So let's go back to the front end, and under the build property, below our target, let's specify the args property, and we'll set that to Vite API URL, and that's going to be equal to https api.domainname, and that should give us the full path of our API. So we're injecting in this Docker environment variable, which automatically gets read from this .env file. Then we're passing it in as an argument to the build process when it runs the Docker file. And then that argument is just being injected in here. And so when we run the build command, it should use whatever value is in our .env file here. Since we added an argument here, we also need to remember to update our dev Docker compose file. So I'll go up to the front end service, and again, I'll add the args prop. And in here, we can just hard code the value because again, we're running everything locally on the static domain. So this will be https api.auth.localhost. So now this should keep our dev environment working just as it did before. Although one thing to note is this argument, it's only going to be used when we build on this line. When we're running in development, it's going to build our code, but ultimately it's the Vite dev server that's running. And the Vite dev server is actually just going to use the .env file in your front end directory. And so this API URL is actually what's going to be used when the dev server is running. So if you ever need to update it, then make sure to update the .env file, not the argument that's being passed in. I just need to set it here so that it doesn't break on me when it tries to build. All right, so that should be it for our configuration. And now let's go back to the root directory and try to run our production Docker compose file. So from the root, we can do docker compose up and the build flag. And by default, it's just going to look for docker-compose.yml. When you're running it locally and you want to use the dev compose file, you'll have to add a -f flag and specify the name of the file. So you'll do -f docker-compose.dev, and then you could do up, down, or build, all the same commands. Just make sure to have this -f flag to use the dev YAML file. So in my case, I want to run the production one, so I'll just keep it as docker compose up. And it looks like our environment variables are not getting passed in. And I think I just need to get rid of this dash here. Let's retry that. And here it's building. So let's open up our terminal. Now we should be able to see the different stages of our build. So we see development, then our APIs using the production one, and same thing for our front end. We're using the development stage and then eventually copying the files here to our production image. And it looks like all of our containers spun up. And let's check our Docker desktop here. Great, so that looks like they're all running. Now let's actually test it in our browser. So I'll go here and just refresh. And our app is still working as it did before. I can see my profile. Let's just log out and log back in. And that looks like it's all working as it did before. To verify that we're using the compiled code, we can go in and inspect one of our containers, like our API, and we can go into the file system here, and under /app/dist, you'll see that all of this code is just JavaScript. There's no TypeScript, and this is all of our compiled code. So if we look at one of these files, you'll see that this was definitely the compiled version. So we can verify that all this is working, and the amazing thing with Docker is we can just now go onto a VPS, clone the repo, run docker compose up, and it's going to spin up this entire production stack, and we can verify that it'll work because it's working locally on the same containers that will run in production. In the next video, I'll show you how to actually take this setup and deploy it to a DigitalOcean droplet, and then hook up a real domain to it with a valid SSL certificate. And we'll also use a custom email to send from that domain in Resend. That's it for this video. Thank you guys so much for watching. Leave a like if you enjoyed and subscribe if you haven't already. It would help me out a ton. Let me know in the comments if you have any feedback or what you guys want to see next, and I'll see you in the next one.